lesson 57, I believe. Is this 67? Lesson 67. I docked this 10 lessons. And lesson 67 is going to be on classifying systems of linear equations. So there's some review in this, but we're going to get some new definitions and terms that we're going to need to use moving forward. So I'm going to tell you that number one is a system of linear equations is a set of linear equations with the same variables. We never defined it that way, but two or more linear equations with two variables is a system of linear equations. So the variables need to be same. Number two, what's the slope and y-intercept there? Slope is 4, y-intercept is -7. Now number three, slope is wow. All right, y'all listen. Y'all aren't doing this very well. Some of y'all are shouting the same incorrect answer over and over. If you solve this for y, you would subtract 6x, and divide by -2. So that's going to be positive 3x. And 18 divided by -2 is -9. So the slope is positive 3 and the y-intercept is -9. Now, it's okay, and we're practicing some mental skills here, but if that were a test question, you should be very meticulous about showing the steps that you would use to arrive at that solution. What is the slope of a line that is parallel to this line? -5, right? Because we would subtract 15x and we would divide by 3 and we get it. Now let me ask you a question. What do these lines look like? They all look like what? Right, so they look like this. Now, I do want you to write this down. Standard form, because this is going to be a time saver for those of you who mention it, I want you to write this down. AX plus BY equals C. All right? Solve for y, what would we do? Subtract AX from both sides. All right? And that'll give us BY equals -AX plus C. And then do what? Divide both sides by B. And then we've got something here, don't we? Slope-intercept form, which means the slope of a line in standard form is -A over B. The y-intercept is C over B. Okay? All right, so let's go back up here and look at these things that are... Now, these aren't all technically in slope-intercept, but this works technically in standard form because they have some reducing to do. But Bo, if we look at this one, the slope is the opposite of A over B. That's positive 3. Right? The second one here, this slope is the opposite of 15 over 3. That's -5. What's the slope of this one? Opposite of 1 over 4. But this is asking for the slope of the line it's perpendicular to. Now, some of you missed those on your quiz yesterday, which I got to give back. Perpendicular to, what does that mean the slopes are? Opposite reciprocals, right? So the perpendicular slope of -1/4 is positive 4 over 1. All right, so that would be the solution to that one. So this is just another kind of something that you can file away. If a line is in standard form, and some of you will remember this and it'll save you time, the slope is the opposite of A over B. It's a time saver, right? It's going to be a time saver for what we're looking at today, and we're going to use this fact today. In standard form, the slope of a line is the opposite of A over B. Yes?
Would it have to be when you're writing the perpendicular line, perpendicular slope, would it have to be 4 over 1?
No, you can just write 4. I'm just showing the opposite reciprocal. I'm just being technical about it. All right? Today we're going to solve and classify special systems of equations. This is not new. There's really nothing new we're going to do today. but we are going to kind of go a little deeper in solving systems of equations. What are the three ways that we've solved systems of equations so far? And graphing, right? So we started with graphing, and then the next thing we looked at was substitution, and then we looked at elimination, right? Now, that's the three methods that we use. There are some other methods, but they're based in these, so really you don't have to learn any other methods than these. This is kind of it. Elimination, substitution, and graphing will solve any system of equations, whether they're linear equations or not. There's some matrix techniques that you'll learn in Algebra 2. That's just about the only place you'll use those or need those unless you're doing some programming. If you're doing programming with linear equations, the matrices methods would work good because it's easy to program them. And linear algebra classes in college where you'd learn some other techniques. But elimination, substitution, graphing is what we've done. And here's the important concepts we're going to look at for today. A reminder, the solution to a system of equations is the point or points where the two lines intersect. So when we solve it, whether we solve it graphically or whether we solve it algebraically, what we're finding, Charles, is the point of intersection. Okay? The point of intersection is what we're finding when we solve a system of equations. All right? Here's a new definition. You're going to have to write this down and memorize it for the test on next Tuesday. Lines that intersect in a single point are classified as consistent and independent. You need to write that down. You won't remember it if you don't. I promise.
I looked at it yesterday because I did it on my lesson.
Lines that intersect in a single point are consistent and independent. All right? What are the other options for lines? They can intersect in a single point. They can do what?
They can be parallel, they can not be.
They can intersect in multiple points.
Multiple points, all right. They can be the same line, or they can be parallel and not intersect at all. All right. So that's the three cases that we're going to give names to. Okay. Lines that intersect in a single point are consistent and independent. Okay. Blank lines do not intersect, so they will have no what? Solution. Parallel lines do not intersect, so they will have no solutions. Systems of parallel lines are inconsistent. Charles, inconsistent. There's a definition there. You're going to have 3 or 4 test questions on the Unit 7 test that require you to know these definitions. If you don't, you miss 4 easy questions. There goes an A. There's a letter grade for not knowing these definitions.
No intersection.
Yeah. Parallel lines do not intersect, so they will have no solution. Systems of parallel lines are inconsistent. And the other scenario was they intersect everywhere, right? They're the same lines. If a system of equation consists of 2 lines intersecting, then they are the same line. And these systems are classified as consistent and dependent. Okay? They're dependent on each other. They're the same line. The set of solutions is dependent on the equation of the 2 lines.
Consistent, dependent lines are ones that have intersecting multiple
Yeah,
points.
same line. Yeah, when they're the same line, we're talking about lines that are consistent and dependent. All right? Consistent lines have solutions, right? The ones that are independent, that means they're 2 different lines. Dependent, same line, they have an infinite number of solutions. And the ones that don't have any solutions are inconsistent. So you're going to be asked to classify lines on the next test. Are these lines consistent? Multiple choice. It's going to give you a system of equations and ask you to classify them. So we're going to talk about classifying and solving systems of equations through our lesson today. All right, so I wish these directions said solve and classify. All right. Maybe. Okay. All right, so what would y'all do to solve this one?
Add 3x.
Substitution is the best way to do it, right? Because we already have one of the variables solved for y equals 3x. You should write this down. Everybody should write this down. We're going to substitute 3x in the place of y. So that'll give us negative 3x plus 3x equals negative 4. And what do we get? What's negative 3x plus 3x? 0 equals negative 4. Anytime we end up with a contradiction like that, that should tell us that this has no solutions, right? So this system of equations has no solution. Well, what does that tell us about those two lines? Inconsistent, right? So the system of equations is inconsistent, but what else does it tell us about the lines?
They don't intersect.
What kind of lines don't intersect? Parallel. Now, is there another way I could have shown that these two lines are parallel?
Correct.
Couldn't you take the top line and just solve it for y? What would we get? Y equals 3x plus 4. The other line is y equals 3x. Those two lines have the same slope and different y-intercepts, which means they are parallel and they are not going to intersect. So this system of equations has no solutions, which means it's inconsistent. Okay? You good with that, Sean? Okay? What about this one? What's the slope of the first line?
-1.
The opposite of 1 over 3, right? What's the slope of the second line?
-1/3.
Negative 1/3. It's the opposite of A over B. It's the opposite of this divided by this. So are these parallel? To be parallel, they have to also have what? Different y-intercepts. All right, I don't think they're going to have. If we divide both sides by 3 here, what do we get? 2. What's the y-intercept of the first line? Y-intercept of the second line? Same slope, same y-intercept means these are the same line. This has infinitely many solutions. Okay? Infinitely many solutions.
Wait, does it not have no solution?
No, it's the same. The lines are the same. We'll look at it again in just a second.
All the numbers correct.
Okay? Infinitely many solutions, which means that the system is consistent and dependent. All right? So we are looking at a consistent and dependent system means that the two lines are actually the same. So you got to be careful. When we pointed out that the slopes were the same, some of you jumped on the conclusion that they were parallel lines, but keep in mind that if the lines are the same, then they also have the same slope. Now, what if we just jumped into an algebraic technique? What would this look like? What algebraic technique would you guys use for this one? Elimination would work nicely, wouldn't it? If we multiply this second equation by -3, that would give us first equation still x plus 3y equals 6. The second equation is -x minus 3y equals -6. When you add those two together, you get 0 equals 0, which is always true. Anytime something is always true, that's an indication that we have infinitely many solutions. These two lines are actually the same. All right? So this is a good review of solving systems of equations. It's also a good, we're looking at some new information with the labeling the systems of equations. All right, try this one on your own. Determine if each system of equations is consistent and independent, consistent and dependent, or inconsistent. Now, let me ask you this. Do you have to solve the system to label it? No. What's the best thing to do first? If we're just trying to classify it, what's the best thing to do first? Find the slope. Yep. So go. Try it on your own. So what do we come up with? Consistent and independent. So we're saying that it has one solution. How do we know that they have one solution?
Because they don't have the same slopes.
Because the slopes are different, right? So it's consistent and independent, meaning we have one solution. That means we have different slopes. What's the slope of the first line?
4.
-1 over -1/4, which is +4, right? And then the slope of the second line is -2 over 1, which is -2. These are different. Lines with different slopes are going to intersect in a single point. You're going to have a unique solution, consistent and independent. All right, try this one. This says to graph the lines and check the solution. I just want you to classify it and see. All right, I'll be done. Cooper, what'd you come up with?
I got inconsistent,
Inconsistent. So you're telling me that the two lines are what?
parallel.
Parallel. Inconsistent means no intersection point, and parallel. And that's pretty clear. Real quickly, we see that by taking this first equation, subtracting 3x from both sides, we get y equals -3x plus 2. So we got y equals -3x plus 2, y equals -3x minus 4. Same slope, different y-intercepts. Lines are parallel, right? Parallel lines do not intersect, so this is an inconsistent system of equations. All right? Good? All right, what about this? Read this, Fisay.
Brandon started jogging at a rate of 4 miles per hour.
Well, hold on, stop. Rate, slope. All right, go ahead.
After he jogged 1 mile, his friend Anton started jogging on the same path at a pace of 4 miles per hour.
Ooh, pace. What is that? Slope. So what do they have? Same slope. All right.
If they continue to jog at the same rate,
Oh, same slope.
will Anton ever catch up with Brandon? Explain.
No.
Will he? No, because they started at different times and they're running at the same rate, same speed, same pace. Okay? If the slopes are the same, then we are going to have an inconsistent system of equations. The two runners will never intersect each other. The first runner would have to slow down, or the second runner would have to speed up in order to have an intersection rate. Do what?
What if the path like moves back around?
Well, there still would be.
No, but like say it was one straight path and they were both on it, and so like the first person.
Oh, what if the paths cross and they meet? Now, here's what you don't do. Y'all listen. Here's what you don't do on a standardized test. What she just did. Don't do that. You're overthinking it. Does it tell us anything about the path? No. So we're just assuming that they're taking off and they're running.
They have water in their backpacks.
All right. Your homework is page 439. You got 20 minutes. You're going to start now. A through D, 1 through 10, 13 through 16, etc.
Bring the whole bookshelf.
We'll pass them out now.